Hello children, welcome back to my channel. Now I am dealing with 9th class maths, triangles. In this we are going to do theorem 7.1. What does this theorem says? ASA, it is ASA congruence rule. ASA angle side angle congruence rule. So what is the statement says? Two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other. So two triangles will be there in that included angle. So let me take two triangles here. Triangle, let me name it. This is triangle ABC and triangle PQR. These two triangles are congruent if any two angles. If two angles, so suppose if I say angle B is equal to angle Q, angle C is equal to angle R, and the included angle, these two sides are included. This side is included with these two angles. So between these two, included means between these two angles, this side is there. And this side is equal to this. We need to prove that the two triangles are congruent. It is a theorem, children. Earlier we have learned side angle, side axiom it is. Axiom means what? There is no proof needed. So the statement itself as it is, you have to learn. But here it is angle side angle theorem. Theorem means you require to prove it. By using the axiom, you are proving it. And one more thing, children, because they have given a specific name to it, angle side angle congruence rule, in examination sometimes they may ask you state and prove ASA congruence rule. They may ask. So learn the statement also. It's a very simple statement. If you understand this theorem, you can learn this. Two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of other triangle. So then only we can say the two triangles are congruent. So what is given to us? We have got in triangle ABC, two triangles are there. In triangle ABC and triangle PQR, angle B is equal to angle Q, angle C is equal to angle R, and BC is equal to QR. If in two triangles, if a pair of angles and the included side are equal to the pair of another side triangle and the included angle, then two triangles are congruent. This is the statement. So in this, what is given? You have got two triangles in which two, see, angle B is equal to angle Q, angle C is equal to angle R, pair of angles are equal, and BC is equal to QR, their included side is equal. So what is that we need to prove? RTP. RTP is, we have to prove that triangle ABC is congruent to triangle PQR. This we need to prove. Now when you take proof, in proof, three cases arise. There will be three cases. What are they? First one is AB is equal to PQ, and the second one is AB is less than PQ, and third one is AB is greater than PQ. In all these three cases, we have to prove, children, that means what? In any way, the two triangles are congruent if this property exists. So that means this is possible only when you prove that the remaining side may be greater than or may be less than or is equal to. So basing on that, let us see case 1 proof. Case 1, where AB is equal to AC. No, sorry, PQ. AB is equal to PQ. If AB is equal to PQ, then in triangle ABC and triangle PQR, in these two triangles, AB is equal to PQ and BC is equal to QR. This is given to us. This is what we have assumed. Okay, AB is equal to PQ, BC is equal to QR, angle B is equal to angle Q. This is also given to us. Therefore, triangle ABC is congruent to triangle PQR basing on side axiom which you have learnt earlier, children. So, when you are taking AB is equal to PQ, what did we say? In triangle ABC and in triangle PQR, AB is equal to PQ, we have assumed. BC is equal to QR, they have given. In the given only we have written. And angle B is equal to angle QR also, that value also is given to us. So, triangle ABC is congruent to triangle PQR basing on side, angle, side property which you have learnt as an axiom in the previous case. This is case 1. Now, case 2. Now, let us see what is case 2. If AB is greater than PQ. If AB is greater than PQ, figure will be like this. This is triangle ABC. This is triangle PQR. A, B, C and PQR. So in this case, to prove it, what you need to do is, you have to locate a point P. Locate a point P on AB. Let me write P already PQR we have taken now. So let me write a point S on PQAB such that AS is equal to PQ. So I am keeping a point S here such that BS is equal to PQ. These two are equal. And what you have to do? You have to join CS. You have to join CS. So, when you join CS, you are getting a triangle BCS. So, in triangle BCS and triangle PQR, BS is equal to PQ. This is what our construction. We have constructed this. And then BC is equal to PQ we have constructed, and angle B is equal to angle Q is given to us. Angle B is equal to angle Q, it is given, as well as BC is equal to QR. This is also given to us. BC is equal to QR. This is also given to us. Therefore, triangle BCS is congruent to triangle PQR basing on side property. Why? Because this side is equal to this side, this angle is equal to this angle, this side is equal to this side. So, we can say that basing on side property, these two triangles are congruent. If these two triangles are congruent, see children, they have given already in the theorem that angle C is equal to angle R. If these two triangles are equal, congruent we have got, but angle C is equal to angle R, this is given. See children, in this, how is it possible? Angle C means this angle C is extended outside the triangle. So, it is not possible. So, it is possible only when S lies on A. S lies on A. Therefore, our assumption is false. Therefore, our assumption is false. Therefore, what you can say? Our assumption is false means triangle ABC is congruent to triangle PQR, because we cannot say that S is possible. Therefore, I'll just write otherwise. AB, therefore, AB is equal to PQ. Therefore, AB is not greater than PQ. This is what we say. AB is not greater than PQ. Therefore, triangle ABC is congruent to, therefore, triangle ABC is congruent to triangle PQR. This is second case, children, and we have one more case. I have no space. If you can copy it, I will do the next one. Now, case 3, children. In this case 3, in the earlier case, we have supposed that AB is greater than PQ. Now, if AB is less than PQ, if AB is lesser than PQ, see, this becomes triangle ABC, and this becomes triangle PQR. So here they have given BC is equal to QR, angle B is equal to angle Q, angle C is equal to angle R. This is given to us. So in case if AB is equal to PC, again here also locate a point S on PQ such that QS is equal to AB. So you are locating a point PQ on this one on PQ S point in such a way that AB is equal to QS, and you have to join S RS. S R RS. Join R and S. So if you join R and S, now we are getting two triangles. What are they? I'll write it here. In triangle ABC and triangle QRS. QRS, AB is equal to SQ. This is our construction, and angle B is equal to angle Q. This is given to us, as well as BC is equal to QR. This is also given to us. Therefore, triangle ABC is congruent to triangle QRS. If these two triangles are congruent, you see angle C is equal to angle R means this is basing on side angle side property, children. Now, in this, angle C is equal to angle R if you have taken. Angle R is away from angle C, angle RS. So, in triangle QRS, up to here only angle R is there. But this is also equal, the other part also is equal to angle C they have given. Angle C is equal to angle R, but angle C is equal to angle R given. It is possible. It is possible only when S lies on P. Therefore, our assumption is false. Therefore, AB is equal to PQ. That means what? Triangle ABC is congruent to triangle PQR. Hence, proved. So, in all the three cases, we have proved that triangle ABC is congruent to triangle PQR. I hope I am clear, children. What is the statement says? In these two triangles, if the corresponding angles, a pair of angles, I can say, are two angles and their included angle. Two angles and their included side of one triangle are equal to two angles and included side of another triangle, then those two triangles are congruent. What is given? Triangle ABC is and in triangle ABC and triangle PQR, angle B is equal to angle Q, angle C is equal to angle R, BC is equal to QR. It is given to us. What we need to prove? Triangle ABC is congruent to triangle PQR. To prove this, you have got three cases. One is AB is equal to PQ, another one is AB is less than PQ, and another one is AB is greater than PQ. So I think I have proved AB is greater than PQ first, children. So let me write AB is greater than PQ and AB is less than PQ. Because first say case 2 I have taken greater than. So here also in an order we will be taking. AB is greater than PQ. So let us see the first one, AB is equal to PQ. I think I have already done earlier. So that I have rubbed. But I will explain. AB is equal to PQ means in triangle ABC and triangle PQR, AB is equal to PQ. You can see what you have written, children. I am explaining so that you will have a second explanation. AB is equal to PQ. We said AB is equal to PQ. Angle B is equal to angle Q. It is given to us. BC is equal to QR also is given to us. So two triangles are congruent based on side, angle, side property. Side angle, side property is an axiom which you need to it is only an axiom which does not need any proof. So using that axiom we are proving this. So we have proved basing on AB is equal to PQ, the triangle ABC is congruent to triangle PQR. In case if AB is greater than PQ, what we did, we have located a point. Just I'll draw the figure, children. I'll explain once again so that it will be clear to you. See, this is a case 2 figure for an explanation. I'll rub it once just now. So in these two cases, if AB is greater than PQ, you have to locate a point S upon AB in such a way that BS is equal to PQ. Now you have to join this. When you join this is C. When you join this, already they have given B is equal to angle B is equal to angle Q, angle C is equal to angle R, they have given. But when you have taken this S point, you have got a triangle BCS. In this triangle, these two sides are also equal, they have given. In this triangle, BS is equal to PQ, BC is equal to QR, angle B is equal to angle Q. So, triangle BCS is congruent to triangle PQR. If triangle BCS is congruent to triangle PQR, of course, angle B is equal to angle Q, it's okay. But what about angle C? See here angle, this is angle R. This is angle R. Here angle C is going beyond the triangle. So how is it possible? It is not possible. So our assumption is false. AB is not greater than PQ. Therefore, triangle ABC is congruent to triangle PQR. This is what we have done under case 2, children. This is for explanation sake I have drawn. Now, when you go for case 3, let me draw a line, otherwise you may confuse. So when you go for case 3, what is case 3? Triangle side AB is less than PQ. I'm sorry, children, here I have written other way. Again, I have corrected myself, so please correct it in your notebook. When AB is lesser than PQ, when AB is lesser than PQ, what you are doing? You are keeping a point S on PQ in such a way that AB is equal to QS. Now, in these two triangles, triangle ABC and triangle QRS, AB is equal to QS or SQ, we have done. It is our construction. Angle B is equal to angle Q, it is given to us. BC is equal to QR also is given to us. Therefore, triangle ABC is congruent to triangle QRS basing on side, angle, side axiom. But we know that angle C is equal to angle R, it is given. See children, here angle R, see it is going beyond this triangle QRS. So, but angle C is equal to angle R, it is possible only when S lies on P. Otherwise, it will not possible. Therefore, our assumption is false. Therefore, AB is equal to PQ. So, in all the three cases, we have got AB is equal to PQ and triangle ABC is congruent to triangle PQR. So, this is the theorem, children. Please learn it, write it and learn it. Now, example 3, children. Example 3 says, in the figure, this is the figure they have given, AB is parallel to DC. Parallel means you can keep arrow symbol, and AD is parallel to BC. Even here you can keep an arrow symbol. So you have to show that triangle ABC is congruent to triangle CDA. So what is given to us? It is given that in A, B, C, D, AB is parallel to BC, AB is parallel to DC. AB is parallel to DC and AD is parallel to BC. This is given to us. And what is RTP? These are line segments indicated, children. What is RTP? We have to prove that triangle ABC is congruent to triangle CDA. This is what you need to prove. Now here, let us see the proof. How can you prove? In triangle ABC and triangle CDA, angle CAB is equal to angle ACD. They are alternate angles, isn't it? When two triangles are, when two sides are parallel, this becomes a transversal. So these two are alternate angles. So they are equal. And angle, these two angles are equal. So now let us see these two. Angle BCA, this means this angle. Angle BCA is equal to angle CAD because they are also alternate angles. So these two angles are equal, they are alternate angles. AC is equal to AC, it is common. Both of them are having same side. Therefore, triangle ABC is congruent to triangle CDA. Sorry, children. Basing on angle side angle property. Hence proved. Sorry, children. Again, let me take it. ABCD is the figure they have given. AB is parallel to DC. AD is parallel to BC, they have given. And they are asking to prove that triangle ABC is congruent to triangle ADC. That is what we need to prove. So in these two triangles, angle CAB is equal to angle ACD basing on alternate the angle statement, because these two are parallel lines and this is a transversal, so alternate angles are equal. Angle BCA, this angle, and this will be equal to angle CAD, they are also alternate angles, and AC is equal to AC common. So these two triangles are congruent basing on side angle property. Please note it down. Example 4, children. Figure is given like this. In the figure, AL is parallel to DC. These two are parallel. E is the midpoint of BC. For BC, it is midpoint means these two sides are equal. Now you have to show that triangle EBL is congruent to triangle ECD. Now, what is given? We have got AL is parallel to DC and BE is equal to EC. This is also is given to you. And what is RTP? You need to prove that triangle EBL is congruent to triangle ECD. Now let us see the proof. In triangle EBL and triangle ECD, in these two triangles, BE is equal to EC. This is given to us. And angle BEL is equal to angle CED. These two angles are equal. Why? They are vertically opposite angles. So they are equal. Then angle in triangle, angle EBL, angle EBL is this angle, is equal to angle ECD, these two angles. This angle is equal to this angle. Why? They are alternate angles. Why are they alternate angles, children? Because these two lines are parallel, this becomes the transversal. Therefore, triangle EBL is congruent to triangle ECD basing on angle side angle property. This is how you have proved this statement. So, take it, children, once again. What did they give in this figure? CD is parallel to AL, they have given. E is the midpoint of BC, they have given. So now you have to prove that triangle BEL or EBEBL is congruent to ECD. You have to prove. So we have taken these two triangles in this BE, children, sorry. BE is equal to EC, that is given to us. BE is equal to EC, that is given to us. Angle BEL is equal to angle ECD. Angle BEL is equal to angle CED. This I have to take. Angle BEL is equal to angle CED. Why? They are vertically opposite angles. And angle EBL is equal to angle ECD. They are alternate angles. So the two triangles are congruent basing on side angle property, children. So please note it down. See, children, example 5, they have given the figure and use the information given to prove that triangle DBC is congruent to triangle EAC. Please carefully you see, children. DBC is one triangle, EAC is another triangle. This we need to prove. So let us take the first bit. In triangle DBC and triangle EAC, in these two triangles, DBC means this triangle, that is angle B, is equal to EAC means angle A. This is given to us. And what else they have given? DBC means this triangle side we have to talk about. BC is equal to AC. This is also given to us. Now, angle ACE is equal to x plus angle DCE. Is it not so? Angle ACE is nothing but x angle plus this angle. These two, if you add, you are getting this. And also, angle BCD is equal to x plus angle DCE. Is it not so? X plus angle DCE is this angle. So, x plus angle DCE is this angle. Therefore, we will say that angle ACE is equal to angle BCD. These two RHS are equal. So, LHS are equal. Okay. Therefore, what you can say? Triangle DBC is congruent to triangle EAC basing on angle, side, angle property. Basing on angle, side, angle property. Hence proved. We have proved the first bit. Now the second bit is, they are asking us to prove that DC is equal to EC. We know that triangle DBC is congruent to triangle EAC. Just now we have proved it. Since we have proved it, we will say that their corresponding sides are equal. So DC is equal to CEC. Therefore, hence proved. So this is how you are able to prove this, children. So once again, see in the figure, they have given angle A is equal to angle B and X, these two angles are X, these two sides are equal. Now the question is, you have to prove that triangle DBC is congruent to triangle EAC. So I have taken those two triangles. Angle B is equal to angle A, they have given, and BC is equal to AC also they have given, and angle ACE, if you take, angle ACE is nothing but X plus angle DCE, and also angle BCD is equal to X plus angle DCE. So these two are congruent, means these two angles are also congruent. First, let me write angle BCD, because this is about side triangle of BCD, means let me write angle BCD is equal to angle ACE. Let me write like this, because BCD is the triangle DBC angle and AC is triangle EAC angle. So like that only we need to write. So all these triangle sides should be on this side. All these triangle values should be on right side. So these two triangles are congruent. Angles are congruent. Equal means two triangles are congruent basing on angle, side, angle property, children. So I hope I am clear. Now when these two triangles are congruent, automatically their sides are also equal. Please note it down. Now example 6, children. See, figure is given in this way. Line segment AB is parallel to another line segment CD. O is the midpoint of AD. That means these two are equal. Then you have to prove that triangle AOB is congruent to triangle DOC. And second bit, O is also the midpoint of AD. So O is the midpoint of AD. They said O is the midpoint of AD. This is BC, children, sorry. O is also the midpoint of BC, you have to prove. O is also the midpoint of BC, we have to prove. So what is given to us? We have got AB is parallel to CD and AD intersects BC at O and AO is equal to OD. This is given to us. Then what is RTP? First bit, triangle AOB, triangle AOB is congruent to triangle COD. We have to prove triangle AOB is congruent to triangle COD. And the next one is O is midpoint of BC, means BO is equal to OC. This is also we need to prove. So let us see the proof. In triangle AOB and triangle COD, first proof I am doing. In triangle AOB and triangle COD, AO is equal to OD. This is given to us. And angle OAB is equal to angle ODC. They are alternate angles. And angle ABO is equal to angle DOC. This is also because they are alternate angles. So see children, angle OAB means this angle is equal to angle ODC, this angle. And of course, angle side angle means we have to take another angle. Sorry children, we will take this. And angle AOB is equal to angle COD, vertically opposite angles. Let us take this. We need to take this because A is a property we are proving. So these two are equal. Therefore, triangle AOB is congruent to triangle COD basing on angle side angle property, because angle A is equal to angle D and these two are vertically opposite angles and these two sides are equal. So angle side angle property, basing on that these two triangles are congruent, hence proved. So the first bit we have proved. And second bit, in the second bit we need to prove that BO is equal to OC. We know that triangle AOB is congruent to triangle COD. This just now we have proved. When two triangles are congruent, every side of that will be equal only. Therefore, we will be saying that BO is equal to OC. That means what? O is the midpoint. O is the midpoint of BC. Hence, proved. So, say children once again. In these two triangles, they said AB is parallel to CD, they have given. And AD, O is the midpoint of AD, they have given. You need to prove that triangle AOB is congruent to triangle COD. So first what I have taken, these two triangles I have taken, in which AO is equal to OD. Angle A is equal to angle D, because angle A means what did I write? I have written angle AOB, I have written, is equal to angle ODC. Alternate angles they are. And angle AOB is equal to angle COD, vertically opposite angles. So these two triangles are congruent basing on angle side angle property. That is what the first proof. And second proof, since these two triangles are congruent, their corresponding sides will be equal. So BO is equal to OC. If BO is equal to OC, O is the midpoint of BC, children. That's all. This is example C. Please copy it. With this, I am going to conclude my part today. In the next class, I will be teaching the next part.